Hello folks, I am Georgios Papadopoulos and welcome to this video on CoAP Request Response Model. CoAP stands for Constraint Application Protocol and it is defined in RFC 7252 standard. CoAP is a generic web protocol with low header overhead specifically designed for constrained devices and networks. Now, this video is just one in a much longer series of tutorial videos on CoAP. So if that interests you, you should subscribe and check out the rest of the videos as well. The interaction model of CoAP is similar to the client-server model of HTTP. Indeed, a CoAP request is equivalent to that of HTTP and is sent by a client to request an action on a resource on a server. If the response is immediately available, then it will be carried in the resulting acknowledgement message. Unlike HTTP, CoAP deals with these request-response exchanges asynchronously over the UDP transport protocol. Logically, CoAP could be considered as a two-layer approach. A messaging layer employed to deal with UDP and the asynchronous nature of the messages, and the request-response layer that manages request-response interactions. In this video, we are going to see first the necessary CoAP terminology and the CoAP type of messages as defined in RFC 7252, which will help us in the third part of this video on CoAP request response model. Let's start with the terms that are defined in RFC 7252 and which we will use later in this video. The first term is the endpoint. An endpoint is an entity participating in the CoAP protocol and it is identified with a node or a host. Then there is the sender, which is the originating or source endpoint of a message. Next, there is the recipient, which is the destination endpoint of a message. Then there is the client, which is the originating endpoint of a request. And finally, there is the server, which is the destination endpoint of a request. Now, RFC 7252 standard also defines four types of messages, and that includes the confirmable, non-confirmable, acknowledgement, and reset. So the first message is the confirmable, and it is a message that requires an acknowledgement. Here is an example with two endpoints, the client and the server. Now, in order to provide a reliable message transmission, then the message is marked as confirmable. Then there is the non-confirmable message. It is the message that does not require an acknowledgement. Here is an example of a message that doesn't require a reliable transmission, and such message can be marked as a non-confirmable. Now, note that even though the non-confirmable messages are not acknowledged, but still a message ID is included for duplicate detection. The third message type is the acknowledgement. An acknowledgement message acknowledges that a specific confirmable message arrived. To confirm that a specific confirmable message arrived, the server transmits back an acknowledgement with the same message ID from the corresponding client. The fourth and the last message is the reset. A reset message indicates that a specific message, which can be confirmable or non-confirmable, was received, but some state is missing to properly process it. Here is a scenario where the server is not at all able to process a confirmable message, and therefore it replies with a reset message instead of an acknowledgement. Let us now proceed with the third part of this video, which is the CoAP request response model. The CoAP request response is the second layer in the CoAP abstraction layer. The request is sent using a confirmable or non-confirmable message. Then there are several scenarios depending on if the server can respond immediately or not to the client request. Now, if the response is immediately available, then it will be carried in the resulting acknowledgement message, and this is called a piggyback response. Here is a successful example of a temperature get request with piggybacked response. The value of the temperature is immediately available, and therefore the server sends back to the client an acknowledgement message containing the response. Here is another example of a non-successful temperature get request with piggybacked response. In this case, the server sends back to the client an acknowledgement message containing the response code client error of 4.04 not found, which is like the HTTP 404 not found. Now, if the response is not immediately available, the server simply responds with an empty acknowledgement message so that the client will stop retransmitting the request. And once the response is ready, the server sends it in a new confirmable message. This is called a separate response. Here is an example of a GET request with a separate response. In this example, the server is not able to respond immediately, and therefore it responds with an empty acknowledgement message in order the client to avoid retransmitting the requests. Here it is important to mention that matching requests and responses is done with the token value and not with the message ID, because a response may be sent in a different message than the acknowledgement, which uses the message ID for matching. For more details on message ID and token value, please check out our dedicated video on CoAP message format. Now, when the response is ready, the server sends it in a new confirmable message and without modifying the token value. This new confirmable message, in turn, needs to be acknowledged by the client. Finally, if a request is sent in a non-confirmable message, then the response is sent in a new non-confirmable message as well. Here is an example where a request and a response are carried in non-confirmable messages. And that's all, folks. Thank you for watching, and if you have enjoyed this video, you should subscribe and check out the rest of the videos on CoAP.